Okay, so for the next section, it's actually two sections combined, but I'm going to do it in two videos just because it's kind of long, and the larger my video, the longer it takes to upload and everything. So I'm just going to kind of split it up, and I'll tell you, where to mark where I'm going to be splitting it up at. But we're going to be getting into now what we call the laws of sine and cosine. So, or of sines and cosines. Basically, what these are going to allow us to do is, so far we've been using cosine, sine, cosine, and tangent when dealing with right triangles. Okay. Well, now we have these things called the laws of sine and cosine that let us find measurements of either sides or angles of a triangle, of any triangle. So this is part one. I'm going to go ahead and just write up here at the top. This is part one. This is part one. So the law of sines is what we're going to start with, and then I'll do the law of cosines on a different video. So, like I said, we've practiced using trigonometric ratios to find the side lengths and angle measurements of right triangles. The law of sines shows the proportional relationship between angles and their, and this is what's really important, I'm going to highlight it in a different color, opposite sides. Okay, so this can be used to find side lengths and angle measurements for any triangle, not just right triangles. Make sure that you're keeping the different rules and laws separate. So when you're talking about, if we're just talking about sine, the law of sines is for non-right triangles. And maybe I'll write that in here. Non-right triangles. Whereas so is for right triangles. So don't get those mixed up. Okay? So this law of sine is if I'm given this triangle here, ABC, where the lowercase of each angle, so if this is angle A, its opposite side is lowercase a. Angle C, its opposite side is lowercase c, and same with B. Okay? So given triangle ABC, the sine of angle A over its opposite side, A, see, opposite side, is proportional to or equal to the sine of angle B over its opposite side, which is also equal to the sine of angle C over its opposite side, C. So, basically what this is saying is if I have either two sides and an angle or two angles and a side, I can find another side of that triangle. Okay? So let's kind of put this to use. So the front page is all finding missing sides. So it's important, though, that you pay attention to which parts you're given and which parts it's asking for. So we're going to use the law of sines and set up a proportion to solve for x. So let's look at number 1 here. Okay. So I'm trying to find this side here. So before I even start, I need to identify what side I'm trying to find. Okay, that's x there. I need to see if I'm given its opposite angle. In this case, I am. It's 71. Okay. Then I need to look at what else is given. Okay, I'm given this side 12. Okay, do I have its opposite angle? Yes, I do. Okay, perfect. Now I have enough info. For each side you're given, you have to have its opposite angle in order to be able to set this up to solve. So what I'm going to do here is I'm going to set this up as a trig ratio. So the sine of 71 over its opposite side, x, is going to be equal to the sine of 35 over its opposite side, 12. Okay? I don't have to have the third one. I just need at least 2 of them. Okay? Now all I do is use my cross multiplying and start solving. So I'm going to multiply those 2 and those 2. So I'm going to have x times the sine of 35 is equal to 12 times the sine of 71. Then I'm trying to get x all by itself. So all I do is divide both sides by sine of 35. That's going to cancel those out, leaving me with x equal to 12 times the sine of 71 over the sine of 35. Okay? Now all I do is put this in my calculator. Do it exactly like this. Just make sure you put parentheses around 12 times the sine of 71.
Please report to your office. Mr. Schulte, to your office.
Okay? Then, once I put that in my calculator, I should end up getting out x equals 19.8. So that means this side is 19.8. And so that's how we use our, what we call these laws of sines, in order to find missing sides. So far we haven't found any missing angles yet. I want to skip 2 and 3 for right now, and I want to look at number 4. All right. So here's my side I'm trying to find. But when I look for its opposite angle, I don't have that. So I need to find that first. However, since I know 2 of my 3 angles of a triangle, I can find the third one. Remember, all angles of a triangle add up to 180 degrees. So if I take 180 minus 53 minus 96, that gives me 31. That tells me this angle here is 31 degrees. Now I have my angle opposite my side I'm trying to use. Then I look, okay, this other side here is 27. That's what's given to me. And I have its opposite angle as well. So I'm going to set this up again. The sine of now 31 over x equals the sine of 96 over 27. I haven't been writing these in parentheses. You actually don't have to. I was doing it at first just so you could get the hang of it, as far as that's how it goes into your calculator. So feel free not to, I don't really care. Okay, and then again, same thing. Cross multiply and solve. X times the sine of 96 equals 27 times the sine of 31. And then you keep solving for x, just like we did on number 1. Okay. So let's go and flip it over to the back of the first page. I just want to look at number 7 real quick as well. So when I look at what side I'm given, that's x here, or what side I'm trying to find, I'm sorry, side x, I'm given its opposite angle. So I don't need to find that. However, my side that I'm given, 29, I don't have its opposite angle. So I have to do the same thing I did on number 4 and find that angle. Okay? So you have to look at every piece that you're given and say, do I have this side's opposite angle? Do I have this side's opposite angle? And you use that to find then to set up your proportion and solve for x. Okay, so let's look at number 9. Okay, now In this case, we're given two sides and we're trying to find an angle. Okay, so I tried to do the exact same premise, except for now I'm trying to find an angle, and it gets just a little bit more tedious here. So here's my angle I'm trying to find. Again, I have to look and see, do I have its opposite side? I do. It's 9 over here. Then I look at what other side am I given. I'm given this side here, and I have its opposite angle. Perfect. So I have all the info I need. So now I'm going to set up my proportion. The sine of angle x that I'm trying to find now is over 9 equals the sine of 77 over 14. And then I do the same thing. I cross multiply. So I have 14 times the sine of x equals 9 times the sine of 77. Okay. Then, when I'm solving these, when I'm trying to find either a side or an angle, all I'm doing is solving for x. I'm using algebra. I'm using the things that I know from Algebra 1 to solve. Think of sine of x, sine of a variable as its own term, or sine of a number that's its own little piece. They have to stick together. So I'm trying to get this all by itself right now. So I divide by 14 on both sides. That's going to cancel those, leaving me with the sine of x equals 9 times the sine of 77 over 14. Okay, here's where it gets a little, not tricky, but just different than how we've done it before. So you can go ahead and put this in your calculator and get out a decimal answer. That's what I've been doing. So sine of x ends up equaling, when I put this whole thing in my calculator, I end up with 0.6264. I rounded to 4 decimal places. Then, remember when I have the sine of some angle x equal to a number, I have to use my inverse sine function to get x all by itself. So I would take sine -1 of 0.6, good grief, 6264, and go from there. If you don't want to put this in your calculator and get out a decimal answer, you can, and I'm just going to make a little sidebar thing here. No, you can solve for x by doing sine or inverse sine of, and then typing that whole thing in your calculator. Either way will work. I do it this way just so I don't forget a parenthesis somewhere or, get mixed up, and make sure that I keep all my numbers straight. However, if you do it the way I do it, make sure that when you round to 4 decimal places at least, so that you can keep it really close to accurate. Okay? So then I just put this function now in my calculator, and I end up with x equals 38.8 degrees. And round your final answer, when you're talking about your degrees, to the nearest tens place. Same with your sides. If you're finding a side, round those to the nearest tens place. The only time you don't round to the tens place, or the only time you round to the nearest tenth, is in your final answer. Okay. So 10 through 14 is pretty much, is exactly the same as number 9. So that is the law of sines. And that is what I'm going to do, leave as part 1. So go ahead and do 2, 3, 5, finish 4, 5, 6, 7, 8, and then 10 through 14. I'm going to go ahead and stop the video here, and then this page here, law of cosines, the next page, I'm going to do a separate video. I'm going to call that part 2. Okay, just so that my videos are a little bit smaller. Make sure that you watch both videos. Both. Not just one. You need to come to class with both parts done on Thursday, I believe. Yes, Thursday. these notes need to be completed, part 1 and part 2. So I will go ahead and stop here. You can go ahead and stop and work on the law of sines right now if you want, and then I'll make, there'll be a different video for law of cosines.